Okay, this is a closer look at my phase converter, which that's the converter motor generator portion, and then going up here is the control panel, which has various outlets on the side for different purposes, and it also has the voltmeters at the top for each of the 3 different phases. Then it has one major cord that goes to the converter itself, and another major cord goes to an extension cord where it is plugged into a 40 amp circuit. Now, the running capacitors are right now just sitting in a box because I don't have a permanent cabinet for them to be installed in yet. But those are the running capacitors. And the wires are all color-coded. They are all red, black, green for ground, and orange for the 3rd phase, which in this setup is a stinger. Then right here we have some test leads that I use for testing motors, and that switch box is actually a remote switch which can be used to start the converter from a distance. Now, this panel has a removable front cover, and at the top is a toggle switch that's used to test motors and see if they're okay. In the middle is a 20 amp receptacle to run things, and then at the bottom is a very large manual switch that can turn the converter on and off manually. And then I have added, for extra protection, this metallic ground wire, which is actually does go to the ground, to the service entrance, just as an added measure of safety. Now, on the converter itself there is a thermometer to check the heat when it's been running under load, and it's never gotten to what I would consider a dangerous level. Now, I can start this as simply as flipping this switch, which I will show. You can hear the converter start. And that's it. The converter is now running. It's operational. And this converter, in fact, can run anything up to a 10 horsepower motor. You can see the voltmeters are showing that it's running roughly 230 volts per phase. These are old voltmeters that I set into a wooden box, and then that's the cord that goes around and it plugs in. So this whole assembly could be unplugged from here and plugged into something else. It just makes it easier to take apart if I were to have to move it or something. Now, over here, can't see it very well. Okay, the converter motor is purring right along, ready for business. And then I can simply flip the switch right there. And the converter shuts down. Now you'll notice this converter has no shafts. This was actually made out of a motor I bought at an auction for $1 and cleaned up and put new bearings in it. And both ends are capped, so there are no shafts. That's all this thing can do. Now, plugged into the side, it would be kind of in the middle, and connected to it is a length of cable which goes to this switch box. Now this switch box could be at a very remote location depending on where your three-phase motor is going to be. It could be out at a cordwood saw, a welding machine, what have you. And this operates a magnetic switch which will also start the converter. Just like so. And simple flip of the switch and converter off. Now I can do it again, showing you the voltmeters. Which aren't too terribly dramatic. Now, I'll have to tell you later on what these different plugs are for. This plug right here goes to the assembly with the voltmeters in it. This plug goes to the running capacitors. This plug way in the back here goes to that remote starting cable. This is a plug, I'll have to explain this one later. And then this plug right here is the one that's connected to the toggle switch on the other side, which has these test leads on the end. So this is strictly a test lead cord. And then these leads with the rubber boots on the end are simply hooked to the terminals of a motor and used to test them. Then here is another 4-wire outlet. This one's also 20 amps. Now, to show the inside. Okay, this is the inside of the control panel, which I do have pictures of it diagramming it, but it's not really packed solid full. It's just that this was a convenient size box. This was a 200 amp meter socket, and it just happened to be a handy right size to put the various switches in, outlets and so forth, the magnetic switch, manual switch, and so on, and the starting capacitor. Now this setup is made so that it can run a machine on demand, like a fan, a pump, or air compressor, and this converter will only start when the machine needs it to run. So it has some relays and other controls in it for that purpose. So it looks a bit more complicated than it would have to be for purely manual operation. But otherwise, I run a 7.5 horsepower motor generator welding machine with it, which I haven't had any troubles with. I have started 10 horse motors with it. just so far for the purpose of seeing whether or not they work, and I've tested a whole host of other smaller motors with it. So far I've been more than happy with its performance. Did a few years of research on it, and had a few tips from some people at motor repair shops and things like that. A little bit of trial and error, and this is actually probably the third version that I made, which has a magnetic start as well as a manual start. And I will have to show it running something a little later, but this gives a rough idea anyway. It's not really quite as bad as it looks. The wires are all color-coded. There are some blue wires in there, those are control wires, but I kept the color scheme pretty much the way it's supposed to be throughout. And this entire setup was put together for about $50. Some of those parts in there are from Radio Shack. Some are salvaged. A lot were bought at flea markets and such. And of course, that converter motor was bought at an auction. And the capacitors were all salvaged out of different things like air conditioners, refrigerators, and the like. So I managed to keep the costs down, and if you build one of your own, you can too. These are parts that really aren't too awfully hard to find. But that's it for this portion. I will put the cover back on, and hopefully show this actually running something.